If it's a big red dot, that means it's not recording.
Yeah.
If it's a little square dot,
I know.
okay, thank you. Okay. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Take out, please, your 6D-1. There are two of them. Take out the one that says 6D-1 diagonal hyperbolas. That's what we're checking out today.
Oh, good. I don't know.
Shut it. Shut it or you.
Well, I could try this one again.
Stand up and hot. No, what is That was it.
You'll need to center in the asymptotic positions too. Make sure for all of you have the center isolated and the asymptotic equation as well.
Same exact thing.
Make sure you fill this.
Oh.
I will ask for a test.
I thought it was.
Oh, I hate that expression. I think. Oh my gosh. Yeah.
Turns on the radio and they're like, oh, she's a business today. And I feel it's just like, oh. He's like, no.
I'm not so serious.
Yeah, she's except for this. And she's just like, oh, she's not. Her mom's like, please, we're struggling.
I just remember one time I watched that in my tape.
And that was a failure.
I told him
That's quite interesting.
All right, here we go. Grab your favorite red writing utensil. Here we go. Let me scoot this over so people at home can see me. Number 1. The center of this graph is -2, 1. There should be asymptotes crossing horizontally and vertically there. So the two equations are y equals 1 and x equals -2. To graph this thing, this is a normal height, but it's upside down. So from the center, go right 1, down 1. And also from the center, go left 1, up 1. You can probably just sketch your hyperbola from there. Just chase the asymptotes. Does that make sense? I may need me to sketch it by hand. Okay. Number 2, the center of the graph is -2, 0. So the two asymptotes should cross there. The vertical one is at x equals -2. The horizontal one is at y equals 0. To graph this one, the easiest way to do it, it's 4 times taller, so you can go to the right 1, up 4, and to the right 4, up 1. If you wanted to just get by with only 1 dot in that, you could go right 2, up 2. That's actually the vertex. But any of those points would be fine. On the lower part, it'd be from the center, left 2, down 2. You could also do left 1, down 4, and left 4, down 1. Those would be good candidates for dots. So sketch the 2 branches. So you should have a branch going upper right and a branch going lower left. Does that make sense? Number 2. Scroll down. Number 3. My computer, wakey wakey. There you go. Center is at 2 comma 0. Horizontal asymptote at y equals 0. Vertical asymptote at x equals 2. The easiest dots to use are start at the center, go right 2, up 2. That's the main vertex. And then left 2, down 2. And then branch. Should have something going upper right and lower left. Does that make sense? There are lots of options for the dots. Again, right 2, up 2. It could also be right 4, up 1. Right 1, up 4. Number 4. This thing is upside down, so be careful. The center is at 2 comma 2. So there's a horizontal asymptote at y equals 2. Vertical asymptote at x equals 2. The easiest way to graph this is from the center, left 2, up 2 as a dot. And you could also on the other side go right 2, down 2, and then draw your branches. The two branches should go to the upper left and the lower right. Next page. Number 5, this one, the center is at -3, comma -2. So the vertical asymptote is at x equals -3. Horizontal asymptote is at y equals -2. To graph this one, there's no middle, like there's no easy vertex here. So I would say go to the right 1, up 2, and to the right 2, up 1 for the first branch. Now on the other side, from the center, you go left 1, down 2. You can also go left 2, down 1. Whenever you don't, like, you notice those previous ones, you could just go like right 2, up 2, where you have a perfect one. If you don't have a perfect one in the center, you might want to use 2 dots, just so you can have a good graph. Okay. Like going to the right 2, up 1, that's not the vertex, because it's not dead set in the middle. So I would use 2 points to make sure you're graphing it right. And again, if anybody wants me to work into these on the board, I can. I think that was it for that one. So it should be branches upper right and lower left. Number 6, the center is at 2 comma 3, which means there's a vertical asymptote at x equals 2, horizontal asymptote at y equals 3. And to graph this one, it's upside down. So go left 1, up 2, or you could go left 2, up 1. I do both, just to make it look better. And on the other side, it should be right 1, down 2, and right 2, down 1 would be 2 separate points. Does that make sense? There should be a branch going to the upper left, and a branch going to the lower right. That is number 6. Number 7, the center is at 0 comma -2. Vertical asymptote at x equals 0. Horizontal asymptote at y equals -2. It is upside down and 4 times taller, so you should be able to go from the center, right 2, down 2. You can just put a single dot there. And left 2, up 2. You can put a dot there. You could also have done right 4, down 1, right 1, down 4. And on the other side, you could have gone left 1, up 4, left 4, up 1. Any of those would have been fine. So there should be a branch in the upper left and lower right. And last but not least, number 8. The center is at 3 comma 3. So there's a horizontal asymptote at y equals 3. Vertical asymptote at x equals 3. From the center, go to the right 1, up 2, right 2, up 1 for those 2 dots. On the other side, it's left 1, down 2 for first dot, and then left 2, down 1 for the other dot. There should be a branch in the upper right and in the lower left. Any repeats on those? Okay, questions? Any of those you want to see done? Yeah.
Number 6.
6. Let me see. Oh, sorry, read. So f of x, refresh my memory on math people. Nate, what's another name for f of x? Yeah, f of x equals turns into y equals. I'm just going to rewrite number 6 as y equals, and you see that negative? I would like to put that negative, wherever I put my magic marker. I'm gonna, they put the negative right in front, and then it was 2 over x plus, sorry, 2 over x minus 2. And then it's plus 3. I add the opposite. Put this negative on top. Question? Yeah, go for it. Now if you remember, the form is y minus k equals a over x minus h. That's another reason why I got the subtraction out from the front, because it's not supposed to be there. If you subtract 3 from both sides, you can get the right form. Y minus 3 equals negative 2 over x minus 2. So the center of this thing is 2 comma 3, h comma k. The horizontal asymptote, remember horizontal asymptote is always y equals something. Use the y value. Y equals 3. Vertical asymptote is x equals 2. You use the x value. If there's ever any doubt, sketch it first. Then it should be easy to see. The 2 equations of the asymptotes should cross at the center. So let's do the center. 2 comma 3. I'm going to mark that. I would immediately draw the asymptotes. Then the equations look a lot easier. This thing is upside down and twice as tall. So it's a height multiplier of negative 2. Normally it's over 1 up 1. Not this time. It's over 1 down 2. Over 2 down 1. Does that make sense? Then on this, because there's always a mirror image like that. Over here, it's over 1 up, left 1 up 2. You can also go left 2 up 1. They always come in mirror pairs like that when you do diagonal asymptotes. So the branch should look like this. And this. Make sure you don't get the asymptote. Does that make sense? Next. Any other ones you want to see? How'd it go? Easy? Hard? Easy? No other questions? Alrighty. Go ahead and put that away. Let me finish one quick thingy here. Yeah. I would like you to do a little detective work for me. You got your notes, please. Go ahead and write that down. In the back. Go ahead and write that down. I'm thinking of a conic. And that's the information I'm giving you, which is not much. I want to see if you can reconstruct the equation. So you don't have to graph it unless you want to. You don't have to analyze it unless you want to. Just find the equation. I want Earth. Is there anything you can tell me about this at all? Is there any shape you can tell me that it's definitely not? Go.
Parabola?
It's not a parabola. Why do you say that? It has 2 vertices, yeah. And a parabola only has 1. There's another shape this can't possibly be. can't be a circle. Why? 2 reasons, actually.
Because it doesn't have vertices.
It doesn't have vertices at all, that's the most obvious one, and
Because the eccentricity is not, like, so with the circle it's equal to 1, right?
a circle is eccentricity of what?
0.
0. Eccentricity is not 0, so it cannot be a circle. By the way, that's another reason it can't be a parabola. What's the eccentricity of a parabola? Remember? 1. The 2 ones that I'd have you memorize, a circle has an eccentricity of 0, and a parabola has an eccentricity of 1. Remember, eccentricity is the tendency of something to deviate from a predictable path. Circle is the most predictable path there is. It stays in your field of vision, and it just keeps going around smoothly forever. An ellipse is a little distended. That means it's starting to weave away from expected. And then a parabola is weaving even more, and then a hyperbola is the most. Anybody tell me what shape this has to be? Something tells you. Now, the 2 vertices doesn't help very much, because it could be an ellipse, it could be a hyperbola. Can anybody tell me which one? Awesome.
Would be a hyperbola.
Has to be a hyperbola. Why?
The eccentricity is, it's greater than 1.
Yeah, if you notice radical 15, I mean, I don't know what that is either, but radical 15 is really, really close to what number? Can we tell me? Go.
4.
It's really close to 4, because radical 16 is 4. It's a little less than 4. So if you have a number a little less than 4 divided by 2, what kind of a number are you looking at? Is it bigger or smaller than 1? Correct. Bigger. It's got to be bigger. So if it's pretty much 2, like 4 divided by 2, it's going to be an answer close to 2. It's definitely bigger than 1. So the eccentricity is bigger than 1. It's got to be a hyperbola. Tell me about a hyperbola. Sam, how many vertices does a hyperbola have? 2. How many does an ellipse have? 4. V1, V2 are the main ones, the major ones. V3, V4 are the minor ones. But a hyperbola only uses 2 of them. Can you tell me anything else about the shape whatsoever? Turn on your... Sorry, but I don't know what they said. Can you tell me anything at all about this? Use the detective part of your brain. There are some clues in here. Go. Focal move. What makes you say that?
Because the eccentricity is the focal move over
C over
A.
A. And C is the what?
Focal.
Is the focal move. Now I will caution you on something. This is, like every once in a while, somebody says, like, just pretend this is a, don't write this down, just watch. Let's just, E is equal to 4 over 5. And people will assume, aha, this is the focal move, and this is the, whatever it is. Maybe. The real life one may be this. Catch up? The focal move might be 8. And it's just reduced. In other words, I don't know. There's a good chance that it is radical 15, but it might be 2 radical 15 over 4. So that might be a bigger focal move. So we're not 100% sure, but that's clever. There's like a 60-70% chance that it probably is. No guarantees, but that's a clever idea. What else can you spot? There's something you should be able to provably find. Go.
The center?
The center, how?
Well, it's just that has the 2 vertices.
Right. Halfway in between the 2 vertices must be the center. So what do you get on that one? 2 comma 3. Very good. We've got a center, and is there anything else we can figure from there? Go. Maybe, although hyperbolas don't have one. We might be able to find a radius. Like in this case, what radius might we find? Look at the 2 points. Go. Evan.
Oh, I just had a question.
Oh, okay, go ahead.
Horizontal radius.
How would we tell? There's probably something that would be very smart for us to do at this point. Graph it. Let's see what we, I mean, we can't graph the whole thing, but let's see what we have. 2 comma 5. By the way, I would strongly urge that you label the numbers. You'll thank yourself. And then 2 comma 1. So this is vertex 1, vertex 2. Does that help? Nay. Oh, and by the way, the center is 2 comma 3. Does that find anything for you? There's a measurement you can probably get from there. John? You can get the vertical radius, because the vertical radius comes from the center. How long is it? It's 2. Vertical radius is 2. Couple things going on here. First, you know the vertical radius. Let me write that down. I have no idea what the horizontal radius is. No clue. But there's another clue in here. This is a hyperbola, right? Can anybody tell me anything at all about that hyperbola? Like, can you picture it in your mind? Like how it's doing anything? Yeah.
Would be pointing up.
It's got to be pointing up and down. How do you know?
Because vertices on.
Yeah, those are the only vertices it has. Remember, when you have a hyperbola going sideways, the vertices are sideways. If the vertices are up and down, that means this thing has got to be opening up and down. I don't know where. Does that make sense? A hyperbola only has 2 vertices, the ones that it actually uses. So it's going up and down. So the vertical radius is great. Somebody refresh my memory, oh math detectives. What does A represent in a hyperbola? Play. The leader radius. Guess what you just found? What must be the leader? Horizontal or vertical? Okay. Gotta be vertical, because that's the way it's going. It follows the leader. This is vertical, this is the leader radius, I can spell. Which means it's what letter again? A or B? It's A. We now know that A is equal to 2. You know how I said be careful of this fraction because it might be an enlarged version? Is it? Wes? No, you got it nailed. If A is 2, guess what the focal move is? It's got to be radical 15. It's not a bigger version. This is the focal move, guaranteed. Let me see. Mary, how do you get the focal move of a hyperbola? Just the formula. Radical something.
A squared plus B squared.
Yes, good. Why plus?
Because the equation is, y, x minus y.
Correct. The equation has a minus, so the focal move has a plus. Can somebody use that and dig up some more clues for me? There are several clues on the board so far. We now know that A is equal to 2. Let me just write this down. A is equal to 2. We know that C is equal to radical 15. And we know that 2 is the vertical radius. Yeah, we may be able to find B. By the way, this has to be, no pun intended, the horizontal radius. A is the vertical, so B has to be the horizontal. I don't know what B is. Hey, take over. Yes, welcome back. I want to know if we can find the horizontal radius, which is also known as B. Do we have enough info for that?
Yes.
How so?
You can plug the vertical radius in, right?
Yes. What is the vertical radius? 2. Plug that in. So it's 2 squared. Plus, I don't know what this is, squared equals what?
Radicals plus B.
Bingo. Do you see where we got that? Keep going. Rainey, help me out. 2 squared, first of all, is what? 4. Oh, let me get this so it makes it quick. So we've got this. Radical 15 equals radical 4 plus b squared. I want to get b by itself. What do you get rid of first? The radical. How?
Square.
Square, as long as you do it to both sides. What does this become? Yes, equals. Well, the square and square root cancel.
Okay, so 4
Uh-huh.
plus b squared.
Good. Keep going. Yep. What now?
Sorry, 11.
Uh-huh.
B squared.
And one more step.
And
What do you get?
so
How many answers?
2.
What kind?
Positive and negative.
Positive and negative. One of them makes no sense in this problem. Right, Claire?
Negative.
The negative. Normally I do plus minus square root of 15. What am I saying? 11. Brain, mouth, get together. But b is a measurement. B is a length. It's a radius. You can't have a radius that's negative. So you have just found b. Believe it or not, ladies and gentlemen, you have all the information you need to finish this problem. Can somebody give me the general, without the numbers, just the general formula of a hyperbola? Now there are 2 different ones. One is vertical, one is horizontal. Which one are we gonna need? Becca?
We need vertical.
We need vertical. So what does that start with?
So if we parentheses y
Yes,
minus
mine.
or
What goes with y?
is it k?
K, very good.
So minus
Y
k
minus k
squared
squared over,
over dr
yes, vertical radius
squared
squared. What do we
minus
put here? Minus, good. And then this?
x minus h
Uh-huh.
squared
Uh-huh.
over h on
Good. Squared equals what?
1.
Good. Everybody okay so far? That's the general form of a hyperbola that's vertical. If you had swapped these 2 clumps around, it would have been horizontal. Let me see. Abby, do we know the center of this thing?
2,
2, 3. That's what, comma what? What 2 letters? Plug them in. Y minus what?
y minus 3
Yes.
squared.
Squared over, do we know the vertical radius?
2
2 over 2
squared.
squared minus
Minus x minus 2
Good.
squared
over what?
over radical 11 squared.
Equals
1.
good. Simplify this mess. The top is fine. The bottom simplifies just a little bit. So y minus 3 parentheses squared over what?
4.
4 minus x minus
2
2 parentheses
squared.
over what? It's radical 11 squared. It's easier than you think, actually.
1 or oh,
What happens when a square and a square root hit each other?
they cancel, so it's just 11
It's 11.
equals 1.
Congratulations. You're done. See how that works? Yeah.
I had a question from the beginning. I don't know if I wasn't here for it, but how did you find the center?
Oh, how to find the center? They gave us 2 vertices. I know one vertex is on one side, one's on the other. I graphed them, and the center is always halfway between the vertices.
Oh, okay.
So one way to do it is that they're 4 spaces apart, go 2 spaces.
Right, okay.
Another way is just take the average of the 2 points. Add up the x's, divide by 2, add up the y's, divide by 2. Divide by 2. And that's called finding the midpoint.
Okay.
And that's actually what I did. But yes. That also told us the vertical radius, and then everything else started rolling from there. Questions? Let's see how good of detectives you've become. I'll leave that up for just a second. Now we'll be posting this on YouTube if you missed any of that. I'm thinking of a conic. Now part of this is getting, yeah, go ahead.
May I go to the bathroom?
Yeah, go for it. Sure. Part Part of this is gonna give it away right away, at least the shape. There are 3 problems like this I want to get through today. This is the second. Haven't told you much. There's a conic, a mystery conic. The focus is 1, 5, and DIR, which I'm going to ask you about in a minute, is x equals -2. What on earth am I talking about? This thing's a parabola. How do you know? Yeah, there's 2 things. Parabola. Parabola is the only one that talks about a directrix. By the way, when you get into college, there actually are, an ellipse actually has 2 directrices. You don't need to know that right now. And a hyperbola sort of kind of does, although they're, depending if they might be imaginary. Never mind, just pretend that was a bad dream. The only one that we know of that has a directrix is parabola. There's also something else that gave it away. Yeah. There's only one focus. I didn't number it. So there's a focus at 1, 5, a directrix at x equals -2. What would you recommend I do first? Well, what might be a smart thing to do at this point? Definitely. When in doubt, in a conic, graph. At least see what you're doing. 1, 5. Did I do 1, 5 last time? No. Okay, no. So the focus, actually, I usually like to put a little x for a focus. And then a directrix is at x equals -2. It's not an asymptote, just beware. Oh, can I change something? Sorry. Can you make this 2, 5? It'll make the problem a lot easier, believe it or not. Just move this over 1 space. You would not have thanked me if I had. I'll tell you why in a minute. Everybody all right so far? Let me move this over here. This is 5. Where do you even start? What does a focus and a directrix have to do with a parabola? Where do you find them? Where's the focus in a parabola? Where do you look for it? Like here's a parabola in the middle of nowhere. Where's the focus? What do you think? Yeah, it's inside. It's above the vertex. What if I'm going sideways to the right? Nick, where would you look for the focus? In the middle, on the right-hand side. Yeah. It's inside, away from the vertex. Where do you look for the directrix? Great. Where do you look for a directrix of a parabola? Under it, correct. And by the way, it's the exact same distance from the focus and from the directrix. In other words, here's the vertex. You go the same distance up and down, and you'll find the 2 other objects. Same thing here. There's a directrix here. Like say if you go 3 spaces this way, you go 3 spaces this way, and you'll find both of them. Make sense? Tell me what I can find based on this. Go. You can find the vertex. Where?
It'd be halfway.
Exactly halfway. By the way, does everybody see why I moved this over? It was at 1. Why would that be a problem? It'd be what? It'd be a decimal. It'd be 1.5, or it'd be 3/2, which is a pain in the neck. So here, this is -2, and this is +2. So where is the center?
It's going to be 0,
0, 5, correct. That's the vertex. I would write that, 0, 5. We're going to need those numbers soon. The focus is 2, 5. And then the directrix, can somebody give me the equation for the directrix? Okay. X equals -2. Good. So if anybody asks you to analyze this thing, you got x equals -2 as the directrix. Can anybody tell me which way this parabola is opening? Is it opening up, down, left, or right? Go.
Into the right.
It's opening to the right. How do you know?
That's where the focus is.
Yeah, the focus drags the shape after it. So it's going to be going this way. So I need some more space here. Is there anything in here? Put on your detective caps, mentally speaking, and tell me if there's anything else you can spot. I love you, Mr. Blaine, do I? Okay. Now then, we know the thing's opening to the right. Is there anything else you can tell me about this thing? The fact that it's opening to the right should tell me something about the equation. Think of parabola equations. I'll give you a hint. Yeah, go.
You need a height multiplier.
Definitely need a height multiplier. And I don't know what it is yet, but we'll find it in a moment. It's positive. Why do you know?
Because it's opening to the right.
It's opening to the right. So if it were negative, it'd be opening to the left. So A has got to be positive. Whenever we get A, it's got to be positive. If we get negative, we know it's wrong. Something else. Who's the leader? Go. X. How do you know? Yeah, it's going sideways. X has to be the leader. And we also know that A is positive because it's opening to the right. Can somebody give me the formula for a horizontal parabola? What does it look like in vertex form? You should know the regular vertex form. Just flip all the X's and Y's, flip all the H's and K's. What does it look like? Let me read out from. Go.
Y equals
I'll do the regular one. Y equals A parentheses.
Y minus H, right?
Before you do that,
Oh,
do the regular one.
okay. X minus H.
X minus H parentheses squared plus K. This is the vertical parabola. What's the horizontal one look like?
You just switch that to the one.
Do it.
X equals A parentheses Y minus H squared plus.
Almost.
Or,
These are X and Y also.
oh, yeah.
Y minus K squared plus H. This is the formula we need. Are you still with me? So we know a few things. First, we knew it was a parabola because it only has one focus and it has a directrix. When we sketched it, we found the point in between the focus and the directrix, which we call the vertex. And it's at 0,5. That'll be very handy. We also found by looking at the graph that the thing opens to the right. That tells us two things. First, X is the leader because it has to go, it's going sideways. Second, A has to be positive because it's going to the right, not to the left. Is there anything you can fill in for this equation, given the data you have on the board? Oh, math people. Oh, Sherlock Holmes. What two letters stand for the vertex? Abby, just in general. What comma what?
Oh, H comma K.
H comma K. Do we have the vertex?
Yeah.
What is it?
2,5.
That's the focus.
Oh, 0,5.
0,5. Never read it over here. The vertex is 0,5. Plug it in so far. Some of these you will not be able to plug in, some you will. What do you think? Go ahead. Yeah.
X equals
Uh-huh.
A.
Correct.
Parentheses, Y minus 5.
Yes.
Squared plus H.
plus, and h is what?
Oh, 0.
Correct. We're half done. Actually, 2/3 done. There's only one thing we need to find. Josh, what is it? What are we missing?
Just be A.
We're missing A. Is there anything to find A? They did not give it to us. Go.
Could be two ways you put in the vertex and the x and y in that equation they have, or if c is equal to 1/4, right?
Oh, that's incredibly sneaky. By the way, that's another method. The point is, we're trying to get A by itself. If you can find an x and a y, now the catch, there's a catch. It actually has to be on the parabola, not the focus. It has to be on the parabola. Now, and it cannot be the vertex. Otherwise you get 0 equals 0, which I tried that once upon a time, and I wanted to spit nails when I got to that point. So that's totally clever. If you had any points on this parabola whatsoever, yes, you can do that. Unfortunately, we don't. But there is one last way we can. Go. What's the focal move formula for a parabola? Close. 1/4a. Please write that down if it's foggy. The focal move formula for a parabola is c equals 1/4a. Be careful it is not 1/4 a. Very tempted to do, but those are two different numbers. So, math detectives. Math. Okay. There was a female detective, wasn't there? There was a TV show with this female detective. It was actually pretty good. Whatever. It's called Murder, She Wrote. Anyway, a couple people saw it on cable. Anyway, moving on. How do you use this? Nate, take over. Like, what does this have to do with anything? What is C? Focal move. Do we know what the focal move is? Two. How do you get that?
Oh, because the
Kinda, sorta. That's true, but there's a catch. The focal move in a parabola can be positive and it can be negative. So I want to know which one actually gives you the real focal move. Josh.
is it from the vertex to the focus?
The vertex to the focus. Hence that. They don't call it the directrix move, they call it the focal move. So it's how far did the focus move? And you're right, it moves 2 spaces. Did it move 2 to the right or 2 to the left? 2 to the right. Would you call that positive or negative? So would I. The focal move of this thing is positive 2. The positive is important. If it's going to the right, remember A has to be positive, and so does C. Let me see, no pun intended. That was a total accident. Blaze, take over. Use this thingy. Do we have C? Is what? What is it? Positive 2. Equals what, according to this? 1/4 A. How do you solve for A? It's buried in the basement, which is totally annoying. There are 2 ways to do it. One is a normal way and one is a sneaky fast trick. I'll show you the sneaky fast trick in a minute. Yeah.
You just multiply by 4.
Yes, multiply both sides by 4a. As long as a is not 0, you can do that. And it's not, otherwise you'd have a really stupid problem. What do you have so far?
So, 8A.
8a equals 1. Keep going.
Divide by 8.
Divide by 8. What do you get?
8 equals 1.
Really? Finish the problem for me.
So then you just.
This is what we have so far. Finish it.
So you have, wait, x equals
Uh-huh.
1/8.
Yes.
Parentheses y minus 5
Uh-huh.
squared plus 0.
And you are done. Yeah.
So for the equation you have 2 equals.
I'll second. What's that? I'm sorry.
Okay, just like for the equation there, we're getting A.
Yes. I knew what C was from
Yeah.
here. Okay.
So if you multiply by 4, both sides by 4.
You'd still have A on the bottom.
Oh, so it'd still be 1 over. Okay, gotcha.
Yeah. Yeah. I promised to show you the sneaky fast way. Does anybody remember this? If I have 10 is equal to 20 over 2, does everybody believe me, first of all, if that's true? Okay. I want to make sure everybody's on the same page. This is honestly true. There's a math rule that says you can swap the answer and the bottom, and it always works. Watch this. 2 equals 20 over 10. In other words, when I do C is equal to 1 over 4A, you can swap these. 4A is equal to 1 over C. Always works. The even funnier part is, that this might be harder to remember, you can actually do a piece of the bottom. C is equal to 1 over 4A. A is equal to 1 over 4C. They both work. You can move any piece of the bottom and trade it with the answer. Catch on? Now, otherwise you can just multiply both sides by 4A, which is the normal way to do it. Questions? Going once, twice, thrice. Okay, I want to show you one last thing. It's going to be a partial problem because I don't have like a lot of time. I don't want to erase that.
Oh my goodness, this is a lot.
Oh, wait, sorry, 4. Go ahead and write this down. Last problem of the day. 4x squared plus 4xy plus 1y squared plus 2x plus negative 3y plus or minus 120 equals 0. Write it down. The only thing I'm going to ask what type of conic is that? What do you think? What does it look like? Try the eyeball method, which my old high school math teacher used to call it. Look at, yeah.
Ellipse.
It looks like an ellipse. Why do you say that?
Plus
They're both plus,
coefficients are different.
they're both squared, and the coefficients are different. What if there had been a minus? Then it would look like a what? Hyperbola. What if this had been 4x squared, 4y squared? Circle. There's something that's stopping us from recognizing it by eyeball method.
The XY term.
As soon as you have an xy term, all our predictive powers are out the window. We have to use something else. Courtney, take over.
Oh, okay. What do you want me to do?
I want another type of counting.
Okay.
What shape? This is what we did yesterday.
I was not here yet.
Oh, heavens, sorry, Mary. What in the world? Okay, I think, did we do it the day before? Did you do the
we
b
did it.
squared minus 4ac?
That was yesterday.
Ah, go watch the video on YouTube. Go.
Yeah, just b squared minus 4ac.
Capital B squared minus 4ac. That should sound familiar, even to people who weren't here yesterday. That, it looks like it's from the quadratic formula. It's pretty much the same formula, just big letters and not little. This is called escape strength. If it's less than 0, it's going to be enclosed. If it's equal to 0, it's going to escape in one direction. And if it's greater than 0, it's going to escape in 2 directions. I don't have a lot of time, but let me give you that quick metaphor from yesterday. Assume you're trapped in a bubble of whatever. If you are too weak to punch your way out, you're still enclosed. There are 2 shapes that could do that. What are they? Just what 2 shapes would sort of enclose things? No openings whatsoever. Circle, ellipse. Which shape has 1 exit? Blaze. Parabola. Which one has 2 exits? Katie. Hyperbola. Just, thank you, Will. Now, if you are too weak to break out of this bubble, you're stuck, you're enclosed. It's either a circle or an ellipse. I know we're just about out of time. Second, if you are just strong enough with both your fists to break out one way, it can open in one direction. Parabola. If you're super strong, you can punch this way and get 2 exits. Do it. Nick, finish it off for me. What's B?
4.
Yeah, this is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So, okay, so it's 4 squared minus, keep going. 4 times, which is a?
4.
4 times 1. Calculate.
16 minus 16.
Which is?
0.
What shape is this?
Parabola.
This is a parabola. It looks like an ellipse. It's not. Please stand. No homework. Don't get used to it. There will be some for Tuesday of next week. Yeah, the stuff that, the next worksheet, the people who are gone, you can get it to me on Tuesday. The people who are not gone, get it to me on Monday. Deal? In the name of the Father, of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. All right. Thank you. See you soon. Oh yeah, please. Bye, y'all.